Hello interwebs, welcome to Let's Fix Computers. I got a, this is a Toshiba Satellite C55 with a mega sticker bomb job on it. This thing does not turn on, we've got no power at all. The top lids have been lifted to have a look and stuff, but yeah, there's nothing going on this thing. So the customer reckons it's shorted via a USB port because apparently they were getting messages about USB current overloads and stuff like that. However, I just tried turning it in and powering it on and nothing happened at all. So I'm just going to come at this from a no power perspective. So because I'm plugging it in and there's no power, the first thing I'm going to do is strip down so we can start doing basic checks. See if there's any power getting to the motherboard, that kind of thing. So let's get the covers off and we'll go from there. It's had a fair bit put into this. We've got a SSD in here. Only a BX500, but that's fine. This is, for the record, the BX500 is a cheap SSD and it doesn't have any DRAM, but it's fine, basically. For most modest use cases, nothing wrong with it at all. Got 16 gigs of aftermarket RAM in this as well, so it's got an i5 in it. The Toshiba C55, it's not exactly a prestigious laptop, but you know, with the extra RAM and i5 and a SSD, this thing is probably pretty quick. So yeah, we got some missing screws for the keyboard, that's fine. Okay, pretty clean on the inside. Socketed CPU, don't see those very often these days. Okay, before I plug this in, I'm just going to do a sanity check to make sure we don't have a direct short across the DC jack or something like that. Just because occasionally that happens. Nope, and if I just go to resistance mode, we've got at least, about 160,000 ohms, 160k ohms. So that's completely normal. Normally I expect to see some laptops like HP's tend to have reasonably low impedance. I've seen them as low as like 20 kilo ohms across the DC jack, but we're still talking 20,000 ohms. So there's still a lot of resistance across there. If you're seeing something like a couple of hundred ohms or nothing, you've got a direct short across your DC jack. Fine. Okay, let's plug this in and we'll see what we're getting where. Go over to DC volts. Let's bring the camera in closer. Okay, we've got 19 volts getting into the motherboard because I've got 19 volts going down into the board. Let's see, have I got any? We've got some secondary power supplies over there. It looks like all the really good stuff is on the other side of the board. I'm just going to take some pot shots. Let's just go on one probe on ground. I'm just going to check this fuse here. 3 volts. Okay, I don't know what that is. There's a 3 volt regulator there. That might be the 3 volt. That's probably just the general 3 volt regulator. Anything on this guy over here? No one there. I'm just going to start, I'm just probing around, gathering information at the moment. Just probing these inductors to see if any of them are powered up. No, not really. Okay, I think we might have to take the board out so we can see the other side where the where VN is. Although because we've got 3 volts over here, that suggests something. Although I don't know why there's 3 volts there. Like why is there just 3 volts there? That doesn't make any sense to me. Let's take this motherboard out. All right, now we can see our inrush limiter here. I'll give you a close up of that just so we can have a look. So as you can see, we've got a classic layout here where we've got our voltage is coming in here. You can see 2 red wires. Those come up onto these 2 pins here. And you can see the trace goes straight into this input inductor, which just makes that input inductor is there just to smooth out the spike of when you plug in the charger jack and there's that momentary rough connection as the charger jack contacts. So that just irons that out. And then we're going into, from there it looks like we go through this fuse and then I think we go into this guy And then from this guy, this is the first MOSFET of the inrush inductor. Then I think we're coming out and going into here. And then I think this is our output into the rest of the laptop. I'm going to quickly buzz that out just to confirm. I'm just going to continuity mode. Yeah, so this goes to there. That goes to there. That goes to there. And then this guy goes to other places on the laptop. I'm just going to find a secondary power supply. So here's just another secondary power supply with a couple of MOSFETs here. And here's a capacitor on the input. So we can just touch that and we can see there's continuity to that inrush limiter. So we've confirmed that that is the output onto our main power rail. Now also, is it shorted to ground? It is not. Cool. Okay, right. So we found our main power rail. So let's get this plugged in and let's trace back that main power rail and just see what's coming online. So we're back into a voltage mode on the multimeter. And we go one probe on ground. And so we've got, there's our 19 volt charger voltage. And then on the output of the inrush limiter, there's our 19 volts coming out of the inrush limiter. Cool, okay, so that's all fine. Let's go and check those secondary power supplies again. So once again, one probe on ground. That was the guy I was looking at. There's our 19 volts going into this power supply, and probably the same deal over here. Yeah, there we go, and there it is on the input to that one. So yeah, our main power rail is just fine. That's hunky-dory. What are we missing here then? I'm going to unplug it and I'm just going to sort of have a look around for some short circuits in other places. Ah, okay. So here are the USB ports, which the customer said it was shorted through the USB, and he said he'd been getting alerts there. So looking at closer at these USB ports, if we come down on those, you can see we've got this trace here comes out and around, and same over here. And then there's some capacitors there, so that's just some decoupling capacitors. So we should find that one side of these is grounded and the other isn't. So also you can see that pin there connects to the anchors. So that's our ground pin and that's our power pin. Then that's the USB 2 data lines. And then at the back, we've got the USB 3 data lines. So this guy's our power rail going into the USB ports. And it's shorted on both sides. So there's our short circuit. That's our problem here. Our USB ports are shorted. So as luck would have it, we've got a 0 ohm link here. That goes back around there, back around there, back down to there. So these two rails are connected up via that. Is there somewhere where we can cut this, where we can detach the USB ports, I wonder? Before I spend lots of time looking for that short, I'm just going to make sure that all those pins are fine in there. Yeah, we got no bent pins in any of those USB connectors. That looks fine. So yeah, we don't have any physically bent pins. That's something you always want to check for. It's been a while since I've seen that. However, I went through a phase where just all the time I would see people who had managed to snap off that inside tab of the USB connector by jamming things in the wrong way. And just all the pins would all just be mangled and mashed down into the back of the connector. Well, in fact, the answer is actually right in front of us. Let's go in for the super close-up. Poor man's microscope, go! So here's a closer look at the USB sections that I was looking at. What I wanted to know was, where's my pointer? Okay, there we go, the tweezers will do. What I wanted to know was this 0 ohm link. I wanted to know what that was connecting up. because I was thinking, if we remove that link, what does it detach? Can we isolate the fault? And if we follow that one, we can see that this goes from this bit here, goes up along here, up to this guy. So why is just this port connected with a 0 ohm link, but not this one? Well, the answer there is this one isn't actually USB 3. It has these pins there. However, as you saw just then, it's a black connector inside. So this guy is the USB 3 with the blue connector, and they've put this on a 0 ohm link, and that is basically functioning as just a rudimentary fuse, because the USB 3 port, that guy can supply significantly more current to a device. So they've stuck that on a 0 ohm link just to function as a poor man's fuse. But the bigger issue is the power for this is coming from this chip here, which wah, 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 has a big old burn mark on it. So there's your problem. So this whole thing is probably shorted through that chip. So what I'm going to do is I'm going to remove that chip from the board, and we're going to see if the short circuit disappears. And I would wager that the short will disappear and the laptop will come back to life, albeit with no USB ports at all. So let's see if we can get that far, because a working laptop with no USB is better than a dead laptop. So in comes the hot air, and I'm running my hot air at full airflow, 420 degrees. I usually run at 400 degrees, but recently I'm testing just running my air just a little bit hotter at 420, just to try and get faster results. You can run at 400. However, I have noticed recently I've been struggling with things, so I'm going to go on some of the advice that I've been seeing in the comments and just give it a bit more heat. But you don't always go mega heat because you'll start melting things. It's that simple. Okay, I'm just doing some preheating from a distance at the moment. And let's go in and get this guy off the board. Yeah. We are having an easier time at 420. That was the way forward. Right, so with this, what I assume to be the USB power chip removed, one black probe on ground. And yeah, our short circuit has disappeared. So now we've got ground on that side, but not on that side. So this chip had blown up and was shorting the USB ports to ground via that chip. So what was that chip doing? Well, that was going to be the power supply. I wondered, can I read enough of that model number so we can find out what it is? Let's try. Q11G something. Let's try Googling. Okay, I searched for Q11G USB datasheet as a partial, and I think we might have something here. 4-port USB 2 hub. What's that? No, absolutely not. That's not it. That's not it at all. Nope. No, I can't make out enough of that to get a match. We're going to need a schematic to find out what that is. Fine. Okay, I'm going to come back to that in a minute. Well, I've put the board back into the case and just plugged in the bare essentials to turn on, allow the power button and the screen, but we've still got no power. So even with the short circuit removed, it's still not happy. So we're not out the woods yet. Let's do some more checking. So the issue is that I'm not sure what else might be damaged at this point. So what I'm going to do, I'm going to try and take some pot shots. So we're going back into continuity mode. Beat mode activate. And what I'm going to do is I'm just going to start buzzing out loads of capacitors and see if we can find any more short circuits. Because of course this guy went bang, but you know, we might find that it was more than just that, and that is just the symptom of an underlying cause. So let's see what else we can find. So ordinary capacitor, not shorted on one side, ground on the other. So let's start looking around. Yeah, everything's buzzing just on the side it should do at the moment. What about the pins from the chip we removed? Well, that's a good sign. We only had one ground pin there, so that would suggest that the chip had internally shorted to ground, but it hadn't shorted out on all the other lines. If we found that like half of these pins were all shorted to ground, that would imply that there's a lot more damage than just that blown up chip. But then the other thing as well is that, you know, we don't know where this thing was getting its power from. And this guy's going to also... This thing might also be talking to the PCH. I'm not sure. Let's take the board back out and check the other side. Well, there's not much going on this side of the board. Just peel back this plastic and yeah, there's really not a lot happening here. The chip we removed is about there-ish. So we'll just quickly buzz out some of these top side components and see if there's anything of interest, but I don't think there will be. Hold on a minute. Why is this still hot? Ah, there is something burning there. Who's on fire? One of those regulators is burning up. Which one is it? It's faded now I've unplugged it. We're going to plug that in and chase it again in a sec. Who was that and why didn't I catch that? Like, if one of these guys is shorted to ground, surely its decoupling capacitor would be as well. I'm sure it's that guy. I'm going to confirm it. So this is the point where I would pull out a thermal imaging camera if I had one. I'm going to buy one at some point. However, you can get pretty far without them. Ugh. Friendly reminder that Lewis Rossman went without using one for years. Yes, they're very good, but they're also very expensive. However, I'm going to zoom in. That guy's going to be starting to heat up. And what we'll do, just squirt a little bit of alcohol on that. There you go. See that chip? Just immediately dries out with the alcohol on it. That guy's dead. And that is our controller for these two rails. So that guy's blown up as well. Very well then. Who are you? You are a TI 1225C. TI 1225C datasheet dual synchronous step-down controller. There you go. So with 5 volt and 3 volt, 3.3 volt LDOs. So this chip handles our 5 volt and 3.3 volt rails. And that's why this laptop doesn't turn on, because it's missing its 5 and 3 volt rails. Fine. And if we scroll down a bit on this one to see the different packages, we can just confirm that this one looks correct as well. There you go. So that actually looks like the chip we're looking at now. So unlike previously where I was looking for that USB chip and we weren't getting anything remotely correct. Fine. Okay, so it looks like we need a new one of these as well. Interesting that it's not, well, it's we're not getting any short circuits around it. However, the fact that it's burning up implies to me that it's internally shorted. It just seems to have gracefully failed. So I think we need a new voltage regulator, and we need to replace that USB chip. But I don't know what that is. So let's look up. Let's see if we can find any schematics for this. So what do I reckon the model number of this board is? We've got lots of labels on it. Nothing, that might be a model number, but it doesn't look like a model number to me. Ah, there we go. PT10S UMA. I think that's our guy. I'm going to Google search for that. Some Googling later, and we've got a data sheet. So, table of contents, USB connectors. USB connectors, page 41. That's what we want. So, let's go page 41. 41. Cool. So, here's the USB connectors. And these guys are the power source. So up here you can see that these have been labelled USB VCC, so USB voltage continuous current, constant current. And the pin out matches what we saw on the board. We've got one ground pin and we've got 3 output pins. So these are what we're looking for. So this is our guy, this GMT G545B1. So I'm going to search for that and see what comes up on Google. This is going to be, yeah, freaking all data sheet. I hate this website. You can't find anything on it. What was it? G545. There's a G546. All roads lead back to the same website that never has the data sheet. Fine. Okay, forget the data sheet. Can we just find a replacement? G545B1. eBay. Well, it looks correct, but the markings on it are completely different. Okay, so update on where we're up to with this thing now. I went away and did some head scratching on this because we were stuck with, as you can see, this is the buck regulator. Well, this is the control chip for the buck regulator that is getting super hot. And we've got an ID on this one. So as per the numbers on the chip, this was a TPS 51225. And we've got the full data sheet for this there. So all I've got to do now is jump on eBay or AliExpress and I can get a replacement one of those and we can fit that and hopefully that should get us running again. So far so good. The problem came with the USB power switch chip, which has a big old burn mark in the middle of it, so I can't identify it. Now I got as far as the schematic here. So on the schematic here, we're on the USB page, and you can see we've got USB connector. That one's behind my face, whatever. We've got the USB connectors at the bottom here. And at the top of this page, these are the USB power switches. So these generate the 5 volt at the USB ports. Now, what was confusing me is that there's 2 of them on the schematic here, but there was only 1 of them on the board. And I tried searching for these numbers and I didn't come up with anything useful. I did come up with a USB switch chip, but when I found pictures of it, the image and the markings on the chip did not match what we actually had on the laptop. So I think the schematic I have here is for a slightly different revision or a slightly different model. And while the ones there there's a good chance they would work on the board, but I kind of want an exact match because otherwise if it doesn't fix it, I'm not going to know if that's because there's another problem somewhere or whether it's because I don't have an exact match. So I scratched my head and I was like, I don't get it. Why is there 2 on the schematic but only 1 on the board? And also, how the hell am I going to identify this one with a crater in the middle of it? And then I had a thought, I had a IQ 200 moment where I was like, if there's 2 of them on the schematic, that means that the other one must be somewhere else. So where else are there USB ports on this laptop? Well, the ones that we're looking at on the board here, there's 2 USB ports there. There's USB 3 and a 2, and there is where the switch chip we removed used to go. And the other USB ports are on the left-hand side. There is 1 more USB port that is not on the motherboard. It's on a I/O board that connects to this flex here. And, there's our other USB switch chip. So here's one that has not blown up. So let's zoom in on this guy. There we go. And we have Q13S G547G1. So I started searching for Q13S and I got nowhere. However, when I searched for G547G1, I pulled up another data sheet. So that got me to this guy, which is a power distribution switch, integrated power switch for self-powered and bus-powered universal serial bus applications. And also the model number of this, G547E, is very close to what we have here. This is a G545B. So that confirms that this schematic is probably for an older model laptop or like a different revision of the motherboard. And that explains why when I searched for that chip, I came up with a chip that didn't look correct and had the wrong markings on it. However, these ones, the one that I've found now, this does look correct and does have the right markings on it. And if we scroll down a bit, the other thing as well that I noticed was when we look at the chip, so the markings on that are Q13S. However, the exploded one, that one was clearly Q11 something or other. What was it? Q11? The other one was Q11G, and also it was G something, and then I believe it ends in F1, whereas this one ends in G1. So this one is slightly different to the one on the other side of the board. But if we look into the datasheet, we can explain that. So on the datasheet, as you can see, this is for a G547E, F, or G1. So now we've got the F and the G resolved. And if we scroll down to here, and we look in on this section here, G547 F1, active high 2 amp current, and the G1, active high 1.5 amp current. So that we've got two separate chips. We've got the F1, which is the one that exploded, that is rated for 2 amps because it's got 2 USB ports on them, one of them being a USB 3 port. And then the G1 that is still functional, that's a 1.5 amp rated because that's just a single USB 2 port, so it doesn't need as high a current rating. I'm surprised they didn't use the same chip for both, to be honest, because that would have reduced their part number or the number of parts, but whatever. So now we have a full identification, we know exactly what it is, and we know exactly what we need. So again, I'm going to hit up AliExpress or eBay and find a replacement one of those. Okay, right, my replacement regulator has arrived. Still waiting on the USB chip because that one's coming from China. I managed to source this one in the UK, so it didn't take terribly long. So I'm going to put this guy on because we should be able to get the laptop to start up just with these USB ports not working. And if I can at least get it to turn on with the regulator replaced, at least I then know that I'm not wasting my time. Otherwise, I'm not even going to bother waiting for this USB chip to show up. Because, yeah, not really much point in repairing the power to the USB ports if the laptop doesn't turn on. So, let's get the hot air on the go. And we're going to remove that regulator and stick the new one in. Preheating. I haven't worked on this one in a while. 420 degrees, maximum air. I'd like to not melt this cap if possible, so I'm going to try and angle away from it. There we go. Oh, and the pin 1 is in the top right. Right, now we're going to tidy up the area. We're going to add a bit of flux and some fresh solder there just to make these pads nice and prepared. And that'll make it easier to fit the new one into place. Oops. There we go. I need thinner solder for this. For the people who often tell me, your solder is far too thick. I know. I tell you, actually, as soon as I finish doing this, I'm going to go and order some thinner solder because I just always forget. Do I have my... I've got a spool of... There it is. I've got a spool of crazy thin stuff. However, this stuff is too thin. This is like 0.2 millimeters, and it's really too thin to be useful. Yeah, this stuff kind of just disappears onto the iron, never to be heard of. That's fine. We'll stick that on and we'll touch up the edges. It'll be fine. Actually, I'll stick a bit more flux down there. I was fairly certain I ordered 2 of these, but only one of them arrived. So unfortunately, I only get one shot at this. Generally speaking, when I'm ordering parts, you always buy 2 of them. So that way, if you screw it up, you get another chance. Right, I'm turning my airflow down a little bit because we don't need it on Mega. Nope, I'm just going to back the camera away. Because otherwise the camera is in the way. Whoa, he's spinning around. There we go, and I'll just let that settle. So you see how it's sort of magneted in place. That's where it's sticking to the solder. Now we'll press down on the chip and reflow it. There we go, that is now flat, and we've just pushed out the excess solder. And we'll just go around the edges. That should do it. I'm just going to inspect. Yeah, that edge, I'm just going to touch that side up again. That top row doesn't look quite right to me. All the other edges, though, are fine. No, that one's a bit more. Still not quite right. Let's add a little bit of flux in there again. Okay, 3rd time's the charm. Yeah, that's good enough. That'll do it. And power in. Damn it. That guy just immediately began burning up. Damn. It's the same problem. We didn't have a short to ground there last time. Let's check it again. Oh, that makes me very sad. I think we just hit the end of the line. Okay, we've got some short circuits going on around that area. Okay, I'm going to need to look this up on the schematics and find out what those guys are doing. It looks like it wasn't the regulator. There's something else there causing this issue. If I'm lucky, I haven't blown up my replacement regulator. Let's see what I can find. Okay, so this is the 5 and 3.3 volt regulator. This is the 5 volt side, and on the other side you can see we've got another pair of MOSFETs for the 3 volt side. And when I was buzzing around just then, I found a couple of resistors that were shorted on both sides. And those, pin number 2 goes along here, and this resistor is shorted on both sides. So going over to the schematic, pin 2 is our voltage feedback line that goes up along down here and goes to 2 resistors. So these resistors, we've got ground there, but we shouldn't have ground on both sides. So was the output of the 5 volt rail shorted on both sides? That would be a bit of an issue, and I'm not sure how I could have not noticed that. We should be able to see that from pin 2 of the coil. And I'm 99% certain I checked that and did not find a short circuit. So I'm just going to buzz those areas out again, just to make sure I'm not going mad. Alright, that goes up in the kilo ohms. And that guy's got a kilo ohm on it. So once again, let's double check. So that's ground. That guy's also ground. And that guy's also ground. So I need to double check what those resistors are and confirm that I'm reading this correctly. Because we seem to have a load of grounded stuff. Should be a 15k and a 10k. I'm going to measure those and make sure that they are a 15 and a 10k, because that would confirm that I'm looking in the right place. Well, they're grounded on both sides, so we can't actually tell. I think I might be getting somewhere here. So here's our shorted resistors. Here, and here, and here. So this bit here, this goes back to pin 2, which is the feedback pin. And the feedback pin is going to a resistor divider, which we can see on the schematic here. So these two resistors create a division. And so we've got between the division between the output and ground, it runs that back to the chip. And by looking at this division, the chip can detect the output voltage and adjust appropriately. So we've got one resistor that goes to ground and the other resistor goes to the output rail. We have a short circuit here, but not on the output. So although this line comes across here, there's no join there because there's no dot. So our short circuit is here, but this guy must be operating fine because this is not shorted. Let's measure that in circuit and we should get 15.4k. Now I did think that that was going to be this guy here. However, it's actually this guy here, and I can tell because here's the coil, so here's the output. And if I put my black probe on there, and then I probe to here, we get continuity. So this guy goes to the output. So that must be our 15.4k resistor. I'm just going to set my multimeter into resistance mode, and I should be able to verify that. Yeah, so the 15k resistor is correct. So this guy seems to be absolutely fine. This here says it's open. So that would account for one of the empty pads next door. There's nothing here. That's not present. So therefore, the only other path to ground is via R930, this 10k resistor. So this guy must be faulty. So if I can identify which one is R930 and remove that from the board, the short circuit should disappear. I'm going to go for the one in the top right. It's really hard to tell which it is, so I'm going to take a pot shot. And I'm going to hope for the best. And I'm going to move the camera out the way just because this guy is really, really small. The resistor reads 10k, it's not shorted, so I'm expecting our short circuit to still be there. That's bad news. Let's have a look. Yeah, we're still shorted on both sides. How? There's nothing else there. I was correct, that was the right resistor. So it's got a trace that goes off to the left and it's got a trace that goes off to the right there. I don't know which one is supposed to be the true ground plane. There's nothing to see on the other side of the board. I've got a plastic sheet and just some bits and pieces. It's all a bit busy to be able to figure out where we are though. That much being said, so I've just done a little bit of tracing on the back. So here's where we're working. We're in a direct line up from this USB port. So again, let's just roll you back. From the USB port, we move directly up to this area. And just taking a couple of pot shots here, this guy is also shorted on both sides. And that looks like a capacitor to me. I think that might be just a bypass capacitor just hanging out on the back of the board. I'm going to take that off and just see if we get lucky. I've no idea what he is or why he's there, but let's see if he's shorted out. No, that guy's not reading short. And we're still shorted to ground. So it's not that. Okay, we have found a shorted line now, though. Okay, what I'm going to do, I'm going to put the stuff that I've taken off of the board back on again, just to get back to ground level. Then I think we're going to remove the regulator again and see if the short circuit disappears. Now we've found a short circuit, I have something to work with. I think we can get somewhere. Yes, we are still shorted. Okay, so the good news is we're not shorted through the regulator, which would mean I'd blown up another regulator and I'd have no idea why. The bad news is I have no hecking clue where this short circuit is because I can't figure out where we are on the schematic. Because the schematic shows the resistor divider and that's it. I guess we go to voltage injection. Because that's how you find a short circuit. Ugh. So I guess we're going to inject voltage to find out where this feedback line is shorted. That's the only answer. Yeah. That's the only thing I can think of. I don't understand how we're shorted through feedback. Before I hook up my jumper leads to start doing voltage injection, this guy here, that's a little solder blob jumper. You can see this is an unpopulated jumper. And that is just linking two sections of the board together. I'm just going to remove that solder blob because that will allow us to isolate the short circuit a bit more. And that will make it easier to find the short because there's just less places it can be hiding. It may also help me identify whether the short circuit is actually in the regulator supply or downstream somewhere. Although again, because we're all kind of in the feedback section, I have no idea where we are right now. So let's take that off and see what happens. Okay, so what side does the short reside on? Ah, it resides on this side. Short circuit, no longer shorted, and that's ground anyway. Okay. What's that done for our regulator? Yeah, the reg is no longer shorted. That goes to ground anyway. Interesting. So where the hell does that go? It's just this random spur off of the feedback line? Why does it exist? Where is it going? What is its purpose? I'm going to see if I can find out. So following the traces for this, it goes up here and along here and up here. It goes through a via and comes out there, which I've just managed to eyeball by staring really closely at the motherboard. That goes down there to this resistor. That is shorted, but it's not shorted on the other side. So this is a dead end. That's not our issue. So again, this is just something else that is also monitoring that same feedback line. There is another via about there-ish, which I'm not going to try and show because it'll be really difficult to show, but you can see it with the eye if you stare really closely. So that's in the middle of that pad, which again is shorted. And that goes through to here. There's a little vertical line of vias, and it's the lowest one of them. And it joins through. And it joins through to here. That's the guy there. So we should find that this is also shorted. Which it is. Is it shorted on the other side? It isn't. So again, that would suggest that that is also a dead end. So yeah, I'm not sure where this is because I don't understand where it can be shorted. So, I mean, I guess the only thing I can do is inject power and we'll see if anything gets hot. Because otherwise, I don't know where the hell this thing is shorted. I mean, unless it's internally shorted inside the PCB, but, you know, I'm not really sure how that could have happened. So, let's hook up some jumper wires and we'll see if we can get anywhere. So I'm going to inject from the back because it's a fairly open space. Now, the voltage divider that we were looking at earlier on, which calculates the feedback voltage, that is comprised of a 15k resistor and a 10k resistor. And if they were both 10k resistors, that would give us exactly half. So with the rail running at 5 volts, because it's the 5 volt rail, you'd get 2.5 volts. Because it's 15 on the high side and 10 on the low side, that means we're actually going to be running at slightly under that. So we're actually going to run at about 2 volts. And you can go to a resistor, you can go to a voltage divider calculator and confirm that. So therefore, I know that I can inject voltage at up to 2 volts without doing any damage here, because the whole rail is expecting to get up to 2 volts there. Oh, I don't know if there's enough to solder to here. Maybe I'll be better off soldering to the other side after all. I don't know. Let's see if I can get onto the test pad. My jumper wire is far too enormous for this. We only need a tiny thing. Right, so I've put my jumper wires onto a ground point and onto the test pad of that shorted rail. So if I grab my multimeter, we should find that these two wires have a dead short between them, which they do. Good. Cool, so now we'll join those up to my power supply and we'll inject a modest amount of power. We're going to stick 1 volt on there at... This is a really small line, so I'm going to start down at just like an amp and we'll see if we get anything from that. I'm used to injecting onto much bigger rails than this. So yeah. There. We've gone up to 1 volt at half an amp. Let's turn that off again. What is our actual resistance there? You know, I think I may have made a massive assumption by using continuity mode. There's a mistake that you can make using continuity mode that I live in fear of, where you don't actually have a short, you just have low resistance. But then again, according to the schematic, we should have 10k to ground. So... yeah, look, we've got 2.3 ohms. Okay, hold on a sec. Let's take off the... let's remove the jumper wire. And let's just check if I've just got a bad connection into that rail. However, 2.3 ohms, that's kind of enough. to trigger continuity mode. I'm not sure what the threshold is for continuity mode, but I would expect it to beep at 2 ohms. Yeah. Yeah. 1 volt, half an amp. We could take it up higher than that, but nothing is going to warm up like this. Ow. And then, yeah, no. And then my my injection wire fell off. I'm done. Well, you guys asked for fail videos, so here's a fail video. Anyone else know what it might have been? I'll try and get this one posted before the laptop goes out, just in case you guys have got any ideas. However, yeah, I'm out. I don't know. Last thing, here's the symptoms we've got. We've got no 5 volt rail and no 3.3 volt rail. When we try and power it up, the regulator starts burning up. We have replaced the regulator, and there's no short circuits in sight except for the feedback line, which has 2.4 ohms on it. And 2.4 ohms, I have no idea where that could be. I've tried isolating it as far as I can. Well, no, yeah, I've tried isolating it as far as I can, but I can't find it. Thanks a lot, everyone. I'm done. See y'all next time. Bye.